Okay. A square on the coordinate plane has vertices at -3, 3, 3, 3, 3, -3, and -3, -3. A dilation of the square has vertices at -6, 6, 6, 6, 6, -6, and -6, -6. Find the scale factor and the perimeter of each square. Okay, so let's just go ahead and get started. I'm going to start my pre-image. I'm just going to graph these points. So -3, +3. -3 means starting at the center, I move left 3 spaces. 1, 2, 3. That's right here is -3. And then +3 is my y value, so up 3. 1, 2, 3. So right here is my first point. My second point is +3, +3. 1, 2, 3. And so that would be right here. I'll put some numbers by these. 3, 3, 3. My third point is 3, -3. So again, to the +3 on the x, -3 on the y, right here. And my last one is -3, -3. So on the x, I go to -3. Then from there, I go down to -3 and put a point. If you remember, if you've used a multiplication table, it's the same idea. You find it's always in the order of x, y. Okay, it's always in the order of x, y. So if you find the number on the x-axis first, you can do this with 2 fingers if you'd like. Find the value on the x-axis first, then find the value on the y value, and then move your fingers until they meet. Just like on a multiplication table when you have something like 3 times 5, and you find the 5 on one, you find the 3 on the other side, and you trace them down till they meet. And that's where you're going to put your point for graphing. Just another way to look at it. Okay, so we have a square, and we were supposed to graph it first, which we did. And now I'm going to draw a beautiful square over that. It was interesting. See if it'll fix it for me. Oh, it did. That was nice. Okay. And okay, so that's the first step, was to graph that one. Then we'll graph the next one in red. And our first coordinate is -6, +6. 1, 2, 3, 4, 5, 6. There's -6. +6 might be right under that thing. 1, 2, 3, 4, 5, 6. It's right there. There's +6. Okay. Second point is +6, +6. 1, 2, 3, 4, 5, 6. Right there is my +6 on the x. And trace that up to +6 on the y. There's my second point. Third point is 6, -6. So again, to the 6 on the x. 1, 2, 3, 4, 5, 6, -6 on the y. Get rid of that ruler icon. It's not going away. Let's see. Stickers. Yeah, I can't get rid of that fruit label for some reason, or the ruler label. Okay, last one is 6, -6. So we're going to, -6, -6. We go to -6 on the x. We go to -6 on the y. And again, we should have a very nice square when we draw that in. There we go. Okay, so we graphed each. Find the scale factor. If you noticed, just look at your first point. You can all squares and all circles are dilations of each other. Okay, so you're not ever going to get one square that's not a dilation of another square, because they're squares. All the sides are always the same, and so whatever scale factor you use to get from one square to the other, from one point to the other, is going to apply to all of them. But if we look at our first point, -3, +3, and our first point of the scaled one, -6, 6, what do we have to do to get from -3 to -6 in terms of multiplication? -3 times 2 is -6. For the y-coordinate, 3 times 2 is positive 6. And that would be the same for all the points. So our scale factor is just what did we multiply by to get from our first point, what did we multiply to get from here to here? And we multiplied by 2. So scale factor is 2. And then find the perimeter of each square. Okay, so if we count the perimeter, remember perimeter is just the length all the way around the square. So the bigger one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is 12. Each side is 12. It's a square. And if we add up all 4 sides, it's 48. Okay. For the blue square, it's 1, 2, 3, 4, 5, 6. So 6, 6, 6, and 6. 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So our blue one is 24. And I'll let you look at that and kind of think about it. The last question on this page, which should be part of your assignment, if I get my way, will address that. So look at what is the difference between the blue square and the red square in terms of perimeter, and how is that similar to what you did to each vertice for the dilation. Okay, I think that'll be it for this chapter.